vertex is a point as opposed to a number. So don't forget when you find the vertex, make sure you jot down the vertex as part of your answer. So, you know, a two-part question, you know, even though you got the vertex on the graph, you definitely want to be very specific and say the vertex is, or even just, I usually just write vertex and then put parentheses. And so, cool. All right, so let's just do this just to get warmed up. Eliana, first one, where's the vertex?
At 5.
Give me coordinates rather than a number.
0, 5.
0, 5?
Or 5, 0.
Which?
0, 5.
So let's visualize real quickly. If I put in 0 here for x, I get 0 minus 5 squared, which is 25, right? So 0, 5. So what must it be instead?
5, 0.
Boom, 5, 0. 5 minus 5, 0, 0 squared. Excellent. And when you write the coordinates of a vertex, always write them as a coordinate pair. Don't say the vertex is 5, because then it's like, well, 5 what? That's not a point on a graph. What am I supposed to do now? All right, 1, 2, 3, 4, 5. Boom, there's the vertex. 1, 2, 3, 4. And we'll put a 5 right there on our graph. All right, Justin, talk to me about quick graphing.
You want to know?
I want to know where the next points are.
You go over one to the left and right, and then up one.
Boom, over 1, up 1. You don't even have to say 4, 1 and 6, 1. Just in your head, go over 1, up 1. Boom. Somebody says, I don't get how you do that quick graphing thing. You say over 1, up 1. And if they say why, you say, well, because 1 squared is 1. Oh, yeah. Justin, next set of points.
Over 2 and 4.
Boom, that easy. Over 2, up 4. So from the vertex, I went to 3 and 7, and I went up to 4, and I went boom, boom, and I am the best parabola drawer with the assistance of Eliana and Justin in the history of math. We're that good as a team. Cool. Am I too enthusiastic this early in the morning? But I'm having fun with it. That's all I care about. Eduardo, where's the vertex of the second parabola? -3, 0. Guys, nice job remembering that it's always the opposite, because that's where people always mess up. They say x minus 5, and they go, oh, -5. Well, they say x plus 3, and they go, oh, plus 3. And not one of you made that mistake. Awesome. So -3, 0, 1, 2, -3. There we go. And quick graphing. Quick graphing, Jared. Wait, what? What do I have? Is Jared in this class? What? Oh yeah, it is. Yeah, that's what I thought. And then for a second I blanked, and I was like, wait, is that really Jared? Okay, good. Good. Quick graph, Jared.
Over 1, up 1.
Over 1, up 1. We're going to go out in both directions, and we're going to go up 1. What's next, Jared?
Over 2 up 4.
Over 2 up 4. And I know what you guys are thinking. Hey, Mr. Harmony, why do we have to do it over and over and over again? Why do I have to keep saying over 1 up 1, over 2 up 4, even though we just did it? Well, if we do it enough times, it'll become automatic, and you won't be sitting at home thinking to yourself, there was that thing he mentioned one time, which was called quick graph, but I don't know what to do now. You'll just be like, oh yeah, because we do it all the time. Boom. Nice. All right. Good warm up. Let's move on. Because now, okay, I just got whiteboard cleaner in my eye. Okay, no, it's not bad. It stung for just a second. New question. And my new question is, y equals x squared plus 1. And here's what I want you to do to start with. I want you to make a table that has 3 columns. And I want you to go -3, -2, -1, 0, 1, 2, 3. And I want you to fill out those numbers. We don't need calculators because it's just too darn easy. And then I want you to fill out these numbers. And then we will talk about the graph. Go. Actually, you know what? Let's make this easier because we don't need the 3s. We're not going to graph them anyway. There we go. That's all we really need. Thirty more seconds. Amber, can you fill out that first column for us?
-1, 0, 1, 4.
You guys okay with that? Got a thumbs up from Justin. Got a nod. Uh-oh, I got a thumbs down over here. Eduardo.
If you multiply -2 by -2,
Oh, you made one of the classic math blunders. The difference between -2 squared and -2 squared. So this is big. This is huge. This is not to make anybody feel bad. It's also one of the most common mistakes that people make is they think to themselves, -2 squared, oh, well, 2 squared is 4, so that's -4. And they forget that it's -2 times -2. Huge difference. Very, very important. And guys, this sort of falls right under the category of what I like to call expect your answer. What does that mean, expect your answer? You should already know what the answer is going to be before you start doing a calculation. You might not know the exact number, but when you start to do a calculation, you should have a pretty good idea of whether it's going to be positive or negative, whether it's going to be large or small. If I said to you, hey, you're going to go down to the bank and deposit $20 in the bank and they're going to give you 1.5% interest, how much money are you going to have in 20 years? And you do some calculations and you say, I'm going to have $87 million. Well, does that sound reasonable? No, it sounds idiotic because there's no way you're going to have $87 million. So when your calculator says 87 million, you don't just write down 87 million. You say, oh, I think I made a mistake. Because you're expecting, if you put $10 in the bank at some little interest rate, that you know what, I don't know, $50, $100, a couple $100, but you know darn well it is not going to be 87 million. So having that in your head as you go forward, okay, I've got all these numbers and I got to square them all. What do I expect? Well, what I expect is a whole row of positive numbers. And so when you get negative numbers, immediately your brain should say, whoa, what did I do? Oh, yeah, I forgot. Boom. Let's get rid of all those negatives. And we're good. Cool. Thank you, Amber. Xander.
It's the vertex.
Nope, don't care. Just want numbers.
It would be 5, I guess, and then 2, and 1, and 2, and 5.
Are you guessing and you think, or are you darn sure, absolutely, positively, those are the numbers that go in that table? You think?
Yeah.
Did you take x squared and add 1 to it each time?
Yeah.
So you're 100% positive. You took x squared and you just added 1. Absolutely positive. Good. That's what I like to hear because I guess, I think, maybe, I don't know. What? No, you're perfect. That's exactly it. Good. So here we go. Graphing x squared. Up 1 over 1. Up 2 or over 2 up 4. And I'm looking at the table, but I also know I don't need to look at the table because this is my quick graphing. And I'm going to go dash, 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 and make a beautiful parabola. Thank you, Amber, for that beautiful parabola. Let's graph these points. The vertex appears to be at 0, 1. Plus 1. The next 2 points are over 1, up 1. Oh, look at that. It's plus 1 from there and plus 1 from here. And there and there. And that's also plus 1, plus 1. Hey, you know what? It looks to me like what happened here is that the equation y equals x squared plus 1 just added 1 to each y value. Huh. Interesting. So here's my question for you. Your turn. I want you to predict the vertex and then quick graph y equals x squared minus 2. You can put it on the same set of axes if you want. Can you not see that because of this thing? I wish there was a way to. Okay. I wish there was a way to not have this here, but the cords won't reach to go anywhere. So where's the vertex of that? That's an x squared. I didn't write very well. And then do a quick graph, and feel free to do it, like I said, on the same set of axes. Hey Louise, where's the vertex of this equation?
-2.
Coordinates?
-2, 0.
-2, 0. So right there?
Actually, 0, -2.
Boom. 0, -2. How do I know this? Well, didn't I just subtract 2 from all the y values? So I took that vertex and I just moved it down by 2. Quick graph for us, Louise. What do I do?
You go up, I don't know how to say it, but you go 1, -1, and then -1, I don't know. Okay.
And then what?
2, actually 2, -2.
No, we're not there yet. I got to do the first set. What do I do? Over 1, up 1. Boom. That's how you say it. Over 1, up 1. On both sides. Now what?
Over 2, up 2.
Over 2, up what?
Up 2.
2 squared is?
Uh,
2 squared?
4.
It's 4. Remember, this is x squared. So over 2, up 4. Boom. Over 2, up 1, 2, 3, 4. 1, 2, 3, 4. Symmetry says it's exactly the same on both sides. And whoops, missed. Awesome. So what we've now seen is that this thing appears to move my graph up or down. This one was up, and this one was down. So let's take a look at a more general form of this equation. You're going to need Desmos in your Chromebooks. Y equals x squared plus k. I want you to put that into the Desmos calculator. And when it says, do you want to make a slider for k? The correct answer is yes. Of course I want a slider. Why wouldn't I want a slider? Actually, I'm not sure if it lets you put in y equals or if you have to put in f of x equals. We did f of x equals yesterday. I got a feeling it's the same. Eliana's nodding yes. If you put in y equals, it works. So there you go. Further proof that y and f of x mean the same thing in math. And remember, the website is not desoms.com.
Yeah, I don't want
Hey, you know, the other thing you might do is type in www.desmos.com and then stick a bookmark. Make a bookmark in your browser, and that way you got it every time. Never have to try to remember, what was that website? What do you got?
This is right?
Well, I don't know. Slide the K. What happens?
What if I do wrong?
Oh, look.
It's just a straight line.
Use capital X. And see, now it's got a slider for X, so by using capital X, it saw it as a parameter instead of a variable. I'm pretty sure that Desmos only sees lowercase x and lowercase y as your only possible variables. And if you put in anything else, it will assume it's a parameter like k or like h, which can be changed by sliding it back and forth. Ooh, you put in minus 2. Ooh. So you chose a specific value of k, which is why it didn't ask if you wanted a slider. But if you put in k, it'll let you change it by dragging the slider back and forth. Now, it sort of looks like it's getting skinnier and fatter a little bit, doesn't it, as you drag it up and down? But here's why, is because the more you drag it down, the more of the top you're going to see. So it's not really making it fatter, it's just dragging the whole graph down. And if you think about, if I were to graph more of this red graph, look what happens when I graph more of this red graph. It keeps going out, right? So now it looks like, oh my gosh, I made it lower, it also made it fatter. Well, not really, you're just seeing more of the top half of the graph, which is wider because that's what parabolas do. So let's make a little note of this. K is the vertical shift. Remember vertical, up, down, horizontal, left, right, left with a T, right. Erase this. How do you remember which is which? Well, H stands for horizontal, right? So that's easy. What does K stand for? There's no K in vertical. Ooh, I know. Kangaroo.
What?
Because kangaroos go up and down. They jump. So we got our horizontal shift and our kangaroo shift. Horizontal, back and forth, kangaroo, up and down. Hey, whatever helps us memorize it, right? Whatever works. So let's talk about another graph. What if I were to give you the following equation? Y equals, and I don't want you to do anything in Desmos here. So I want you just thinking about this one. So shove those off to the side, the Chromebooks off to the side. I want you just thinking what happened, what just happened here. I'm going to give you y equals x minus 2 squared plus 1. Where's the vertex? So think about that. What have we just done to the graph? What did we do to the graph of x squared? And where did the vertex end up being? So here's our x squared graph. We'll just put this right back on here. There's our x squared. What did we do to this graph? Give you a second to think about that. All right, let's see what we got. What did we do to the vertex? We have gone through the whole, everybody's answered the question, so we start over again. Here we go. Got math on your mind? Eliana, what do you think we did to the vertex with that equation? Anything you see that seems familiar? Okay, what does the plus one do you think? How does it change it? What direction? Left, right, up, down. Left and right? Which, up or down? Which one? If you had to pick, up? So you think maybe that just took the whole graph and said, oh, let's move it up one. Does that seem reasonable? Seems reasonable to me. I mean, we already solved it. If I add one to every number, what do I do to the graph? I move it up one. So I just added one to every number. There it is. Boom. There's up one. Good. Thank you, Eliana. Justin, what do you think that minus 2 does?
Bring it down.
Down?
Yeah.
What did it do before?
Bring it down.
Did it?
Yeah.
So putting a minus 2 inside the parentheses brought it down?
Oh, no, I brought it up. Yeah, that's positive.
Brought it up?
Yeah. Oh, yeah, I see that now.
What did it do, Justin?
Right, left, right.
Aha! Look at that! Mr. Schick's class is going, why is Mr. Arming banging on the wall? What's that all about? Because I got all excited there. Yeah! The minus 2 moves it left or right. Hey, Justin, left or right? Pick one.
Right.
By how much?
2.
That makes sense. If I just say x minus 2 squared, I take the whole parabola and I move it 2 to the right. But what if I take then plus 1 and just stick it on the end? Well, I just took the parabola that I had moved to the right and I moved it up by 1. So I now have a combination of left and right and up and down. So the vertex is going to be where? Think about that. Jot it down on your page. I'm going to ask somebody in just a second. Where's the vertex if I move the whole thing 2 to the right and up 1? Xander?
I think it'd be like 2, 1.
You think, or you're absolutely positively sure that it's a 2-1, Mr. Ermerding?
I'm sure.
Nice. Nice. Yeah, exactly. The vertex starts at 0, 0, and it just moves around. And whatever I do to the parabola, that's where the vertex ends. I start at 0, 0, and I go 2 to the right and up 1. Boom, my vertex is at 2, 1. There it is. So we can now graph this equation because there's my vertex at 2, 1. Talk to me about quick graphing, Amber. What do I do next? Here I am. Quick graph. Go. Over 1? Up 1. Boom. Over 1, up 1. I am here and here. Now what? Bam. Over 2, up 4. Here. 1, 2, 3, 4. Uh-oh. Here. 1, 2, 3, 4. Now, here's the tricky part. Remember, I'm starting from 1 and I'm going up. just like I'm starting from 2 and going over. So sometimes what people will do is they will accidentally say over 1, and then I'm going to be at 1, and they'll put dots here, and then they got 3 dots in a row. And then they'll say, oh, and I go over 2, and I go to 4, and then they put dots here. It's not from the x-axis, it's from the vertex. Your quick graph is always start at the vertex and go 1, 1, 2, 4, boom, done, got a graph. So there's the graph of y equals x minus 2 squared plus 1. Your turn. Y equals x plus 3 squared minus 2. Find the vertex, draw a quick graph. Don't forget, if you run out of paper, there's a giant pile back there for you. You don't have to label all of them. You notice that I usually only just label a few key points. But you need some so that people know what your scale is. Otherwise, they could look at it and go like, well, does this go by 5s? Does it go by 10s? They wouldn't know. Cool. Nice. So what's that? Oh, okay. Oh, because you've already got a quick graph. I didn't see that. Put a few numbers on that scale. Don't have to put all of them, but just a few, enough to let people know this is what the scale is. Careful there because that almost looks like 1.5 because it's like halfway between 0 and 3, but really it should be. So sometimes what I like to do is I like to actually count off what takes when I'm making, especially when you're at graph paper. Uh-oh. What direction is that going to take you? To the left. And what direction is that going to take you?
Down.
Down. So really that should be -3, -2 instead of +3 and +2. Cool. Uh-oh. X plus 3 takes you in which direction? What makes that equal to 0? What would you have to put into that parentheses to make the parentheses equal to 0? So it should be over here instead of there. So that's the one that's weird. It's always the opposite of what you think. But if you just think about what makes it 0, boom, you got the right answer. All right, excellent. Vertex, here we go. Our survey says, Eduardo, where's the vertex? Vertex is at -3, -2. Guys, remember, this is always opposite. And if you think about what makes the parentheses 0, that's how you'll always remember that that's the right one. So -3, -2. 1, 2, 3. there's -3, 1, 2, there's -2. Every time you make a graph, there need to be some sort of numbers on the axes. You do not have to label every number on the axis. Notice that I never do. I almost never go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I put on some key ones because anybody looking at my graph says, oh, well, that tick is 2 and there's only 1 tick there, so ticks go by 1. Okay, they know. There's enough information there. Normally what I'd probably do then is, but I ran out of room, is that then I'd put a 5 right there up on my axis. So I've got the 1 and the 5, and they can look at it and go 1, 2, 3, 4, 5. Okay, good enough. They know what my scale goes by, and they know where that point is, and that's the important one. All right, awesome. Thank you, Eduardo. And Luis. Quick graph. Go.
So starting with this -3, 2.
Boom.
You go up 1 and up. I forgot how to say it, but up 1, down. I'm not sure yet.
Go on, you can do it. Where am I going? Here I am, right there at the vertex.
Up 1, 1
Up 1, 1 to the side. Yeah. We'd normally say it the other way, but it doesn't really matter. You can go up 1 over 1 or over 1 up 1, both directions. Now what, Luis?
up 2 to the side. Or up 1 and 2 to the side.
2 to the side. How far up?
Up.
Well, then just here.
Or up 2.
Here. What's 2 squared?
4.
Up how much?
Up 4.
Boom. Over 2, up 1, 2, 3, 4. Guys, remember the whole point of this is that this is x squared. The reason I have that pattern is because it's the number squared. It's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Boom, I've got a parabola. And I don't really need to make more than a couple if I'm just asked to do a quick graph. I want 2 sets of points, 1 squared, 2 squared. Cool. So let's now take a look at this. What did we just do? Well, we took the horizontal shift and we took the vertical shift and we stuck them into one single equation. So what does that look like in Desmos? Well, let's put in f of x equals x minus h squared plus k. How many times is it going to ask us if we want to make a slider?
3.
What? What's a better guess? 2. 1 for h, 1 for k, right? What's the correct answer when it says, do you want to make a slider? But of course! Of course we want a slider. Come on, open them up, type it in, go, go, go. And then drag those sliders back and forth. Drag the H slider back and forth. Drag the K slider back and forth. Watch that all over the place. Don't lose control of your parabola. Somebody might get hurt.
Yes.
We're doing good, sir.
We're doing good.
Good, good, good. That's how I have to hear.
You hate to be dragging parabolas all over your calculator screen and accidentally put somebody's eye out. Little brother go running crying to your mom. Mom! He hit me with his parabola. And then mom's gonna ground you, and it's just gonna be a nightmare. Control is the key. I'll shut up now. What do you think? Did it work? Are you seeing it go back and forth? Are you seeing it go up and down? And where does the vertex always end up? There's the question. Where do I see the vertex in that equation right there? Anybody want to take a guess on that one? Where do I see the vertex in this equation, x minus 8 squared plus k? I'll take a volunteer on this one.
Is it, H, okay?
Everybody drag your slider until you've got f of x equals x minus 5 squared plus 1.5.
That's a lot.
I know. Having to drag it all the way over to 5, I bet your dragging finger's just getting exhausted now, huh? Drag h to be 5 and drag k to be 1.5. And then look at your graph. Where's your vertex? Put your hand up if your vertex was at 5, 1.5. I got one hand. I got two hands. I got 3 hands. 4 hands. 5 hands, 6 hands, 7 hands. Yeah! How many people put up their hands because it was easier than doing it on the computer screen, and that was what Mr. Harmony was expecting. Raise your hand if you hate to raise your hand. Guys, we're getting there. We now can look at this parabola and tell you exactly where the vertex is for any parabola. I give you an equation, you say, oh, there's a vertex. Boom, you can start graphing. It's that easy. Any questions about this so far? Okay, so we got time. So here's what I got for you. I got a worksheet. Well, it's both on paper and I'll talk about that in just a second. It's in Google Classroom. I can also print it out for you if you prefer. But let's think about this. But I've still got 15 minutes left. The worksheet just deals with this equation. Oh, that's one other thing. Get out a highlighter if you got one. Because I want you to highlight these things in your notes. If you do not have a highlighter, all is not lost. I want you to find those 3 things, and my green highlighter just ran out, apparently, if I push harder, but no, throw it away. Who does not have a highlighter? Sorry, that was a terrible throw. Oh, that was totally my fault. Highlight those 3 things so that you can go back and find them later. Guys, remember the purpose of having notes is to be able to go back when you're working on stuff and say, oh, I can't quite remember that. Because Mr. Harmony went through it, and we did one example, but that was 2 days ago. When you're done with my highlighters, go ahead and toss them back to me. Luis, you got a highlighter? Oh, Eduardo's going to hook you up. There you go. Highlighter. It was a little bit better, but I also had room to reach in. Amber?
How does it feel?
Okay.
What do you mean? Not sure.
All right. So here's what we got. We've got the ability to graph any parabola that looks like this. And we know that when we graph it, we've got a vertex at h comma k, and it goes 1, 1. 2, 4. One, 1, 2, 4. Every time. So I want to do a little demonstration. Jared, are you a good catch? Okay. Here's the thing first up, but we're not quite ready for the catching part, but we will be. I'm picking you because you're okay with trying to catch it. If you throw something into the air, Justin, you listening?
Yeah.
If you throw something into the air, everybody listening? It makes a parabola. Goes up, comes down, and it will be a parabola. That is a physical law. We got gravity. You throw things into the air, they make parabolas. You launch a rocket, the second that motor shuts off, the rocket goes and it makes a parabola. Kick a ball, throw a ball, have water spray out of a fountain. The second there's nothing pushing it, it makes a parabola. So I'm going to throw this to Jared. Jared, I'm going to try to throw it pretty flat. So it's going to come in pretty quick, okay? So, parabola number 1.
Oh, that was like some dart thing you did there.
Okay? Parabola number 2, ready? Parabola number 3. You see the problem there? With our equation? I threw the ball 3 times. Here's my throw. Here's Jared's catch. And the first time it went like this. And the second time it went like that. And the third time it went like that. But if I look at the vertex on each of these parabolas, if this is 1 and 1 and 2 and 4, there's no way that this could also be 1 and 1, and there's no way that this could also be 1 and 1. Every parabola can't be 1, 1, 2, 4. Because otherwise, how do I get 3 different parabolas starting at the same place and just going higher and higher and higher? Obviously, that parabola is steeper than this parabola. So it can't be 1, 1, 2, 4 like we did on all of our basic parabolas. So that means we need something else. We need something else in that equation that would allow us to make the parabola steeper or flatter. And the question is, where in the equation could it go? So let's take a look at this equation. We've got y equals x minus h squared plus k. And we know that this moves it up, down. And we know that this moves it left, right. We know that we cannot change this. This is a variable. You have to leave it as x because otherwise you don't have an input variable. And we know that this is also a variable. This is our output variable. Choose x, it tells us y. So the question becomes, where could we put another number that might affect this equation another way? Jared.
I'd say in front of the parentheses.
Is there anywhere else that we could put another number? Oh, by the way, here's one other thing. We can't change that either. Because if we change this, it's not a parabola. The 2 makes it a parabola. So Jared is absolutely correct. If we change this number, all it does is move it up and down. It doesn't change the shape. If we change that number, all it does is move it left and right. It doesn't change the shape. If we change this, it's not a parabola anymore. If we change that, well, then we're just putting in one of our input variables. And if we change that, well, then we're just putting in an output variable. There's nowhere else left to put something except right out in front. So let's do this. Let's start with y equals x squared, because it's always a good place to start. And I want you, in your Desmos, to type in the following. You know, it doesn't need to be in a box. I want you to type in y equals 2x squared. So you're going to put two graphs on the same screen. And I want you to type in actually three graphs on the same screen. I want you to type in y equals 1/2 x squared. And you can just type 0.5 if you prefer, or you can type 1/2. And I want you to figure out in the next couple of minutes what the difference is between the three graphs. You're going to have three graphs all on the same screen. I don't know if you guys know, but you can change the color of a graph, I think, by clicking off to the left of the equation. Or does it automatically give you three colors and you put in three equations? Sweet, that's even better. I also think you can change the picture by clicking on it and dragging it around to get it to be in a different spot. I see some of you have the origin right smack in the middle of your screen, and some of you have it up or down on the screen. I think you click and drag and it will just move it around. So make some notes in your notebook. What does each of them do? What's the difference between each of those? Yeah. I'm just exploring because I haven't used this. I've used it a little bit, but not much. Not 100% sure either, but I think holding down the control key and then dragging it, maybe trying to figure out how you change the axes. Can you click on a number and drag the numbers? Somebody click on a number on an axis and then drag that number. Does it make it wider or narrower? Aha. Cool. So yeah, check this out. Oh, wait, what did you, oh, Louise just put two fingers on the, what's it called? Touchpad, thank you. It went right out of my head. And then just moved his fingers apart and together, and it took the whole graph and stretched it and squished it. That's cool. So let's take a quick look. How much time we got? We got just a couple minutes left. I know that y equals x squared. You know what? I don't need to be that high up. I know that y equals x squared looks like this. There's my vertex. There's my 1 and 1. There's my 2 and 4. There's y equals x squared. 2x squared. What's the difference when you're looking at the graph, Jared? What's the difference in that one?
Slightly narrower.
Narrower. Goes up faster. Wait. How much faster it goes up? Huh? Twice as fast, maybe? We'll talk about that next week. But for now, enough to know that the 2x squared looks like it goes up faster. And last question, since we've been through all the popsicle sticks, who wants to volunteer? Half x squared.
You don't have a tucker stick.
What?
You don't have a tucker stick. No, it's on the table. No way. No, that's right.
Have I never called on you?
I've been waiting.
Tucker, answer the question. What about 1/2 x squared? What's that gonna look like on the graph?
Feel like lighter.
Yeah,
Lighter out.
lighter. Another way to think about that is it goes up slower. And we'll talk about specifics on Wednesday. All right. Any questions? Okay. Would anybody like a snack? Here's what we got today. We've got Pillsbury mini bagels in a variety of flavors. The flavors are strawberry cream cheese, cinnamon creamy cheese, not cream cheese, sorry, my bad. Not actually cream cheese, it's creamy cheese. Looks like those are the two choices. Wow, if somebody wants a cinnamon creamy cheese, there's one of them. You should speak quickly. And then we got orange juice. So, come and grab a snack if you'd like
Just
it.
like busted.
We are going to have T3 now. We are going to stick around here for T3.
My leg. My leg.
I'll try to buy it.
Doesn't hurt to try.
Yes, and if you take one bite and it's really gross, the garbage can is right over by my desk.
Almost did it. Wrong one.
So just a reminder about cell phones. Before you walk through my door, they're turned off and in your backpack. And they're not out of your backpack until after you have walked out of my door at the end of the period, okay? I don't like the distractions. You'll notice my sign. Why would we just pretend it's 1995? Because that was the year before they invented cell phones. There was no such thing.
Good morning, Meridian High School. Please stand for the Pledge of Allegiance. I
Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
This would be really good with milk.
There will be an SFA Zoom meeting at 4 p.m. The Zoom link is in the SFA Google Classroom. If you are leaving school early, this includes running start students and those students that only have one period. Please check into the office before you leave so we can have document and parchment time. Thank you. And for the joke, what do you call the ant who fights crime? I don't know. A vigilante. Have a good day, Meridian.
You guys know why we make you sign in and out? Do you know who is legally responsible for you as a minor from 7:55 until 2:35 on a normal school day when we don't have all this stuff? Us, yeah. If I were to mark Justin as being present,
I could rob a bank.
and then Justin were to get hit by a bus on railroad during my class, the first thing they would say after they said, "Oh gosh, is that Justin?" would be, "Why did you mark him present? Why don't you have him?" So yeah, it's one of those weird legal things. And so
My classroom totally got skipped. They didn't bring us any grub.
that's annoying. I have extra. Did you want any? You're good?
This stuff and busting.
Did everybody get one? Are they worth having?
They are.
If you would like to take my extra, I got 5. Cool.
That's so weird.
Yeah, well, I would definitely throw things at the lady when she comes back. Yeah.
You want us to do the CW transfer?
Okay, so that was where I was gonna go next. But I figured I'd let you have your snack and relax a little bit for a minute here. So here's what we are going to do now. There is a worksheet. It is in Google Classroom. It is called Classwork. Number something. I don't know. It's called Classwork. Is it? What's it called? You got it open, Tucker.
Day class worksheet transformation.
Day one.
Excellent. Guys, it looks like this. On the front, there are 4 equations, and it asks you to identify the vertex and graph the equation. On the back, there are 4 graphs. It asks you to identify the vertex and write the equation. You may do it on your Chromebook, Canvas, DocHub, whatever. I like Canvas way better. I don't know if you guys have all played with Canvas. DocHub's horrendous. The problem with DocHub is that the document is on the DocHub server. So when you're trying to draw on it, it's actually sending a signal to the DocHub server to draw this, and then sending it back to say, and now you have drawn this thing, which is why it lags and puts junk all over it. It's messy. Whereas Canvas, your file's actually right there on the Chromebook, and you can change colors and change pens and all this good stuff. You may do it on that, or I can print it out for you if you really, really, really want to do it on paper, but you are going to turn it in Google Classroom. So you will then take a picture and turn it in. You guys know you can take pictures of your stuff with your Chromebooks? What? Because there's a camera there. If you got a camera, it turns out you can take a picture. Crazy coincidence? I think not. It's just how it works. So, does anybody want a paper copy of this versus working on your Chromebook? Who would like a paper copy? Anybody?
Taking a picture sounds too technical.
Anybody? You all good? Okay. So that's what you're going to work on. We've got until 9:40. Please make sure you get this done and turn it in. There will not be homework, but I do expect you to get this done. You feel robbed
Yeah.
because I didn't give you homework?
No, half of this doesn't even have cream cheese. I felt robbed.
It wasn't cream cheese, it was creamy cheese. Let's be accurate.
Creamy cheese.
Whatever grossness that refers to. You wonder why I'm not eating one of the snacks?
Why?
I don't trust them.
You know?
They should just give us those cheese sticks, like mozzarella cheese sticks.
At 9 in the morning, Tucker?
All right, so let's get our worksheet done.